Alright, so we're on our new unit, which is exponential functions. Our first topic here is going to be geometric sequences. So how are exponential models represented in a recursive notation, and how can they be analyzed and represented in function notation? So we're actually not going to call it function notation, we're going to call it a explicit rule, and we'll get to that within these notes. Okay, so what is a sequence? A sequence is a set of numbers that have some kind of pattern within them. So for example, I can say the set of even numbers is 2, 4, 6, 8, ... And it doesn't have an end because even numbers go on forever. So a term is each specific number in the sequence. So they all have A's. The little subscript tells you their position. So A1 is going to be the first number in the sequence. A2 is the second number in the sequence. AN is somewhere over here, and this is going to be the nth number in the sequence. So the 20th or the 30th, whatever position I want, I denote that with a little subscript of n. Okay. The first formula we're not going to use very often. We're going to use it here to start us off, but this one's not as useful as the explicit formula. This one's called the recursive. It's an equation that tells you how the nth term, a sub n, is related to the previous one. So we know a1 is the first term, so it's the first number in the sequence. An is the nth number in the sequence. And a formula here, whatever this equation is, that tells us how do we get nth term by using the previous ones. We'll get to an example of that in a second with the actual formula. Alright, so take a look at this first sequence here. We have 1 6, 1 4, 1, 4, and then 16. It wants us to describe the pattern and then give the next three terms in the sequence. So here, something's happening between 1/16 and 1/4, between 1/4 and 1, 4 and 16. So whatever the pattern is here, it's going to continue. If I can just look at the whole numbers, the fractions are going to display the same thing. So here, 1 times 4, or 1 times what is 4, times 4. And then 4 times what is 16? 4 times 4. And that should work for these other ones. So if you get your calculator, if you do 1/4, so 1/4, and then you take that and you multiply it by 4, you see that it's 1, which is the next one. So here we can say this one's times 4 as well. And then 16 would be the same thing. It's going to say 1/16, and then we're going to do times 4, and we get 0.25, which is the same thing as 1/4. So here, describe the pattern. Here we just say it's multiplying by by 4. And then it wants the next three terms in the sequence. So 1, 2, 3. Well, we're ending with 16, so 16 is this one. And we call this one A1 because it's the first one. A2, A3, A4. So this is A5 here that it's ended with. So it's asking for A sub 6, A7, and A8. These are the next three terms in the sequence. So here we multiply by 4, 16 times 4. Then we're going to do times 4 again, and then times 4 one more time. Alright, so again, get the calculator. And right now your phone calculator should be good enough, or the computer calculator. Very soon though, you're going to want to download the other calculator, because we're going to need it. Okay, so this one is 64. 16 times 4 is 64. And then I take it and I do times 4 again. And get 256. And then one more time times 4. 1024. So this is actually what a recursive is. You need the previous one in order to get the next one. So you have to go in order for the recursive formula. When we get to the explicit formula, that one you can just plug it in and it'll give you the answer, whatever number you want. But for this one, you have to go in order. Alright, so this sequence here is called geometric. Because each term is determined by multiplying a common or non-zero constant to the previous term. Okay, this constant is called the common ratio. So here the 4, we say that's R, which is the common ratio that I multiply by. Alright, so now we're going to get the formula, the explicit formula, and then we're going to use it for the two sequences at the bottom. Okay, so here is the rule for a recursive formula. I gotta tell you what the first one is. So I say A1 is the first number. So this one's always going to be the first number in the sequence. And then I tell you how to get all the other numbers. So here, this one is how you get so AN, I'm going to say is the next number in the sequence. And you get the next number by taking the previous one. So that's what AN minus 1 means. It's the one right before N. And you multiply that by the ratio. So again, in order for us to get the last term, we have to know all the terms before, and then we can find the next one. Okay, so determine whether the sequence is geometric, and if it is, write the recursive equation. So for it to be geometric, that means that we multiply by the same one each time. So from here to here, here to here, here to here, we got to be multiplying the same number. So the way we figure it out is, you can guess and check numbers to see which one multiplies, or you can just divide. So here, if we do 6 divided by -2 to negative, we get -3. That's what the first one is. So times by -3. Now all the other ones have to be -3 in order for it to be geometric. So 6 times -3 is 18, so that one's good. So times by -3. And then make sure you do check them all, because sometimes they try to trick you when they give you the first one is the same, but then the last one's not. So make sure you do check them all. Alright, so here we get times -3 again, and it's 54. So you say yes, it's geometric. And then for the recursive formula part, so you always say what the first number is. So A1 equals the first number, which the first number here is -2. So -2. And then you say, to get the next one, you take the previous one. So this is always going to be there. AN equals AN minus 1. But then this number is going to change. So to get the next one, you multiply it by -3. So that's all this means. It's basically saying the words that we did in the sequence, but as a rule. So you start with the first one, and then to get the next one, you take the previous one and multiply by -3. That's what this is saying. Okay, so if we look at B, 8 times what is 16? Well, I know that's times 2. But here, what's the common ratio to get to 24? I know it's not 2, but to figure out what it is for sure, you divide. You do 24 divided by the previous one, 24 divided by 16 is 1.5. So this one is times 1.5. So right there, I know it's not geometric. Okay, but again, to check, you can check the last one, but as long as one of them's not the same, you say no. Okay, but to check what you multiply by, you just do 32 divided by the previous one to get your ratio. So this one is now times 1.3 repeating. So again, because they're not the same, then you just say it's not geometric. So here, we would say not geometric, because you're not multiplying by the same number. Okay, but you only need 2 of those in order to tell. Okay, so that's basically what we're doing here in the notes. Looking at the next the next page. Now I give you the formula. You have to find the next terms in the sequence, the first 5 terms. So here, in this is the recursive formula. In the recursive formula, the ratio is given by the number that you multiply by. So here's the ratio for that one, and here's the ratio for that one. So R equals 3 here, and then over here, R equals 0.5. Alright, so now we want to find the first 5 terms. So what I like to do for these, when it asks for the next 5 terms, or the terms, is I like to put little spaces. So here's the first one, we call that A1, and then we're going to do A2, A3, 4, and then 5. So A3, A4, A5. So over here, 1, 2, 3, 4, 5. So A1 is the first term in the sequence, which they have to give you in a recursive. So here is the first one. That's going to go here. And then we're going to take each one of these, and we're going to multiply it by the common ratio, which is the 3. So 1 goes here. And then to get the next one, we times it by 3. Times 3, times 3, times 3. So here I can do the first one. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. And then towards the end, you might need your calculator because the numbers get really big really fast. So then you just do 27 times 3 is 81. So this last one's going to be 81. And that's all it wants here. The common ratio, and then the next 5 terms. Okay, so this one over here, A1 is the first one, 162. But now we're multiplying by half. So we're multiplying by 0.5. So I'm taking half of 162. Here, 162. Actually, let me delete all this other stuff. See if I can see it a little better. Okay, so over here, 162. And then I'm going to multiply that by 0.5. Or divide it by 2, whatever you want to think of it as. So here I'm going to get that that one is 81. So now I multiply by 0.5 again. And I get that the next one, the third one, is 40.5. And I am going to start getting some decimals. So from here to here, I multiply by 0.5. So times 0.5. And I get 20.25. And then one more time, times 0.5. I get 10.25. 0.125. Okay, so on the homework, if you happen to get decimals, don't round them here because the decimals are important. Because if you round, it's not going to end up being 0.5 exactly when you multiply. So you do need the decimals, or you can do them as fractions. So here, we multiply by 0.5. You can change these to fractions if you want. Okay, so the bottom part is again telling you if it's geometric or not, and then if it is, we'll just find the common ratio. So here, a geometric sequence is an exponential function. This is actually the new chapter we're getting into. The new unit is called exponentials. And R is the common ratio that we're finding. So for this one, we want to see if it has a common ratio. And if it does, then we can say what it is. If it doesn't, then we just say it's not geometric. Alright, so here, 16 to 24. So I don't know what you multiply 16 by to get 24. So what you have to do is divide 24 by 16. So go backwards. 24 divided by 16 is 1.5. So 1.5. Now if all the other ones are 1.5, then we're good. So here for this one, we do 36 divided by 24 to see what we multiply by to go forward. So again, 1.5 here. Don't stop there. Just because the first two work doesn't mean they're all going to work. Make sure you do check all of them. So 54 divided by 36 is, oh, did I do that right? 54 divided by 36 is 1.5. So since they're all 1.5, we say yes, it's geometric. And the common ratio is 1.5. R equals 1.5. Alright, coming over here. So that is smaller. Again, to get the calculator in your computer, you just type in calc at the bottom and it'll pop up this calculator. Or you can just use the one on your phone. Okay, so here I can figure out the first one. 1 times what number is 4? Well, 1 times 4 is 4. But I don't know what you multiply 4 by to get 9. So right there, that's kind of telling you it's not geometric, but to figure out for sure, you do 9 divided by 4. 9 divided by 4, so the next one, from here to here, is 2.25. So right there, I see that they're not the same, so I can just say not geometric. You don't have to check them all. You could check this last one too. It's not going to be the same. And even if it was the same as one of them, they all have to be the same. So as long as two of them are not the same, you can stop and say nope. Alright, bottom one. So from here, from 23 to 17, I gotta divide. So 17 divided by 23 is this decimal. So I'm going to round it here, but I'm going to know that I rounded. So 0.74. Then you do the next one. 11 divided by 17 is a different number. Times 4.65. So again, right there I can stop and say that it's not geometric. If you notice here, you're actually subtracting. So here 16 minus, or sorry, 23 minus 6 is 17. 17 minus 6 is 11. 11 minus 6 is 5. When it's adding or subtracting, that is a different type of sequence. It's called arithmetic. but we're not dealing with arithmetic sequences, so we can kind of ignore that. But there is a pattern for adding and subtracting. It's just not what we're doing right now. Okay, and then the last one. Here, what would I multiply -4 by to get 8? Well, 4 times 2 is 8. To make it a positive 8, it has to be negative. Negative, negative, make a positive. And then 8 times what is 16? 8 times 2. But again, to make it a negative, negative times a positive times a negative is a negative. And then here, let's just check if it's -2. So if I do -16, 16 negative times 2 negative is 32, so that one's good. And then times -2 again, so times 2 negative is 64, -64. So these numbers are all the same. So I can say yes, it's geometric. Geometric. And my common ratio is -2, because that's what I'm multiplying by. Okay, so the last part of it deals with the explicit formula. So an explicit formula is a formula that allows you to find any number in the sequence, not just the first, second, third one, but any one down the line. So here, a formula that gives you a sub n as a function of its term's position in the sequence. So again, a sub n is the nth term. So instead of having to go 1, 2, 3 all the way to n, I can jump straight to n using the little formula here. Alright, so this next example gives us the explicit formula in the sequence, and it wants us to find the first 5 terms, and then without finding the ones in the middle, it wants us to go and find the 8th one. So this is where this one is useful, because we don't need them in a row, we just need to plug these numbers in. So here we're going to find 1, 2, 3, 4, 5, and then we're going to come down here and find 8. So a sub 8 equals. This is where it's helpful to have this as in have a graphing calculator instead of your phone or your computer calculator. I'll show you how to do it in the computer calculator. But again, you are going to want that, where'd it go? The Inspire calculator or the 84 to do some of these computations. Okay, so what we're going to do now is for the first one, a sub 1, we're going to take the number 1 and we're going to plug it up here for the exponent. So we're doing 1 minus 1, which is 0, and we're raising that to the 1/2. So if you turn your phone sideways, I know on the iPhones, you get more options. Here, if you go to scientific, you get more options. We want an exponent that's not just a squared. So here, this is going to be a 0. So we're going to do 1/2, 1/2. And we want to raise this one to the 0 power. That's going to give us 1 times 3 is 3. So you can do it on these calculators. It just takes more work typing it in. If you had the graphing ones, it wouldn't take as much work. Okay, so now for the next one, we're going to plug in 2. So 2 minus 1. So we're going to do 1/2 again. 1 divided by 2. To the, so exponent 1 power is a 1/2. I'm going to do times 3 because that's in the front. So here I get 1.5. So A2 is 1.5. Notice the order I'm going in. You do the exponent first. So up here, you're going to do 3 minus 1. 3 minus 1 is 2. So now you do the fraction to that exponent. So 1/2 exponent, 3 minus 1 was 2. And we get this decimal. And then you do times 3, which is 0.75. So 0.75 is A3. You can try to type it all in at once. So for example here, for the fourth one, for A4, I'm going to try to type this all in at once on this calculator, but then I'll show you how to do it on the other one, which might be better. So you can do 3 times parentheses 1 divided by 2 exponent, and then here you're going to need to put this in parentheses as well. So parentheses 4 minus 1. And you get that decimal, 0.375. Okay, so it doesn't matter how you type it in as long as you go in order. So again, I'll do that all together for A5 here. So now we're typing in a 5 for the exponent part. So 3 times parentheses 1/2 exponent parentheses 5 minus 1. You do have to put the parentheses for the exponent part. Otherwise, it's just going to do 5, and then it's going to minus 1 from the whole thing. You want the minus 1 to be in the exponent. So here we get the decimal 0.1875. So now for the last one, I'm going to show you how you would do it in the Inspire if you're going to do it that way. Okay, so we're going to do 3 times parentheses 1/2 exponent, and here we're going to do 8, since that's the number we're trying to find, minus 1. So let me pull up the Inspire. So 3, no, I just want a calculator page. 3 times, let me get out of here really quick. 3 times, and then I want it to be a fraction, 1/2. I mean, you can put the parentheses, you don't have to if you stack the fraction like this. But I mean, you can put parentheses around it as well. And then you do exponent 8 minus 1, and we get, this one automatically gives you a decimal or a fraction. If you want a decimal, you just put the little, you can come over here and change it to a decimal. So how do we do that with one button again? No. I forgot how to do that in the calculator. Menu, oh yeah, menu, number, and then convert to a decimal. Enter. And we get this long. So I'm not going to write that big old long decimal. I'm just going to leave it as this fraction. 3 over. So here, 3 over 128 was a 8. Okay. So again, either way, you can use your phone or you can use the Inspire. You're going to want to get the Inspire because it's going to make some of the other ones a lot easier. But it'll work for now. Okay. And the other good thing about if you have the Inspire, if you type all of this into a table or into an equation, you can just look at the table and it'll give you all the numbers. So that's what I'm going to do for part B here. I'm still going to get the first 5. But now I'm going to type them into the table instead of doing one at a time. A4, A5, and then A8 there. And so over here on the table, let me just pull up the whole thing. So I need to add a graph. So second page. Okay, I'm going to go home. I'm going to add. I know that I need to save that. I'm going to add a graph. And in this one, I want to type this part over here. The AN is the y equals, or the f of x equals. This is the part I want to type in. So negative 0.25, negative 0.25 times 5 exponent n minus 1. So times 5 to the, instead of n, we're just going to put x minus 1. So again, we really don't care about the graph. It's a weird looking graph. We want the table that gives us those numbers. So Control T gives us the table. And there we go. 1, 2, 3, 4, 5. We can just copy those down. And then we can go to 8 to get that number. So negative 0.5. Let me come back over here. So the first one was negative 0.25. And then the next one is what? Negative 1.25. And then negative 6.25. Negative 31.25. And the fifth one is negative 156.25. So negative 156.25. And then it wants me to go all the way to number 8. So skip 6, 7, and then just go to number 8. And it wants me to copy that one down. So here's the 8 one. So this is the number I'm copying down. Negative 19,531.25. So you do want all of them here. I know the numbers get pretty big. On the homework, you are going to want to write that big number. Okay, so if you have a calculator, it makes it a lot quicker to get numbers like this. I'm not going to ask you to do anything like that right now, but it makes typing these ones in at the end to find the end value a lot easier. But your phone calculator will do it. The computer calculator will do it. It just, you have to be careful with your parentheses. Okay, so here's what the explicit formula looks like. So if I give you this equation, the AN here is the one that I want. This is the one that it asked for. So the next, I guess I'm gonna say it's the new one, the new number that I want. The 1 in the front is the first number in the sequence. The R here is the ratio between them. And the exponent's always going to be n minus 1. So this n here is the same thing as this n here. So you can just plug it straight into the formula. Okay, so we're using this formula and we're trying to make an equation now. So here I'm going to write the formula over here. A sub n equals a sub 1 times r to the n minus 1. So we're trying to find a formula for a sub n. A sub n equals, well, what is a sub 1? A sub 1 is the first number, which it tells us here, a sub 1 is negative 4. So this part is negative 4 times it tells us what r is as well. R is -2. So here r is -2. I'm going to put that in parentheses, and I'm going to leave it as n-1. So this is the rule. So right here, this is the rule, the explicit rule for this sequence. But now it wants us to use the rule to find the 8th term. So we can go through, we can do 1, 2, 3, 4, 5, 6, 7, 8, or we can just plug in the number. So what we're going to do in the calculator, either in your phone or on the Inspire, is plug in 8 into this formula right here. So go and plug in -4 times parentheses -2 exponent 8 minus 1. So if we're looking for the 8th term, we plug in the 8 for n. So I'm going to do it on both, depending on what you have so far. So here, let me do it on your phone real quick, or on the computer calculator. So for this one, all this stuff. So 8, I'm not going to plug in. I'm going to start plugging in where the -4 is at. So -4, so 4 negative times parentheses 2 negative, close the parentheses. You do need parentheses around this one. That one's important. And then we do exponent. The 8 minus 1 also needs parentheses. 8 minus 1. Oops. Parentheses. And we get 512. So this is telling me that the 8th number in the sequence is 512. So 8 equals 512. Now again, you could get that by going in order. So here you could have -4 as the first one, multiply by 2, multiply by 2, by 2, by 2, by 2, all the way till you get to 8. So this is 1, 2, 3, 4, 5, 6, 7, 8, and that number would be 512. You could do it that way. It's just easier to plug it in this way. Okay, so back over here in the Inspire, if you want to use that method. So I'm just going to go and calculate. So here it was, what was the number again? -4. -4 times -2. So -4 times parentheses -2 to the 8 minus 1. And we get 512 again. Again, doesn't matter which one you use, as long as you can type it into one of them. Alright, and then the bottom one wants the same thing. The bottom one wants a formula, and then it gives us what to plug into the formula. So the formula, I'm going to write the formula down first. A sub n equals a sub 1 times r to the n minus 1. So plugging in what it wants, a sub 1, the first term is 800. So 800 times r is 1/2. So 1/2. And I'm going to go ahead and plug in the n here. A, and it wants the 6th number in the sequence. So I'm going to do 6 minus 1 as my exponent. Okay, and then here we'll type it in the computer calculator. So we're going to do 800 times parentheses 1/2. Oops, I didn't do my parentheses. 800 times parentheses 1/2. You do need the half in parentheses when you do these. Fractions and negatives need to be in parentheses. I would just always put parentheses around whatever this number is. And then you do exponent